Hello again, everyone, and welcome in this fourth part of chapter Equilibria. During this video, we will be given a definition for a buffer solution. We will see how a buffer solution can be made and also how can this kind of solutions control the pH values, and we will be ending by taking a look on how to calculate the pH of a buffer solution. By definition, a buffer solution is a solution in which the pH does not change significantly when small amounts of acids or alkalis are added. Once we will be adding H plus ions or OH minus ions to a buffer solution, its pH will not be changed significantly. So let's see first how can we make these solutions. And actually we can make buffer solutions by mixing together a weak acid and its conjugate base or vice versa. Weak acid and its conjugate base or a weak base and its conjugate acid. Let's see this example here. We have ethanoic acid, which is a weak acid. Actually, this acid is dissociated to small extent in water. Then, once it's a weak acid, so the amount of H plus ions and the methanoate ions is very low in solution. Now, what we will be doing is adding this conjugate base. And from where we can get it? Actually, we can get it from its salt, from a salt which containing this anion. Okay, so by dissolving the sodium methanoate in water, it will be dissociated completely to give Na plus ions plus the methanoate ions, which are considered to be the conjugate base of the acid, which is ethanoic acid. So now in the buffer solution, ethanoic acid molecules are in equilibrium with hydrogen ions and ethanoate ions. So by mixing the acid, in this case the ethanoic acid, with the conjugate base, we will be forming a buffer solution. And the equilibrium in the buffer solution will be the following one, which means ethanoic acid will be in equilibrium with H plus ions and the ethanoate ions. And we can say that in this equilibrium, we have a relatively high concentration of ethanoic acid. At the same time, we have a relatively high concentration of ethanoate ions. Okay, let's see now how a buffer solution works in a way to keep the pH constant. So, if we increase the concentration of the H plus ions, which means we will be adding more H plus ions, or we will be adding an acid to our buffer solution. So what will be happening? At this stage, following to Le Chatelier's principle, this reaction will tend to shift to the left in a way to consume the added H plus ions to reform the equilibrium or to refine the equilibrium, which means that the added H plus ions will be reacting with the ethanoate ions in a way to form the acid, and the reaction will shift to the left until the equilibrium is reestablished. Actually, due to the large reserve supply of ethanoate ions, this will ensure that the concentration of the ethanoate ions in solution does not change significantly. And then by combining with the H plus ions to form the acid, the concentration of the H plus ions will decrease till the equilibrium is reestablished and the pH does not change significantly. And now let's see what will be happening if we add the alkali, which means the OH minus ions. So at this stage, by adding OH minus ions, they will be reacting with the existing H plus ions to form water. And actually, this will reduce the concentration of H plus ions. Then, following Le Chatelier's principle, this equilibrium will shift to the right, which means that the acid will be dissociated in a way to form H plus ions until the equilibrium is reestablished. Then also here in this case, the large reserve supply of ethanoic acid will ensure that the concentration of ethanoic acid remains constant and does not change significantly. So the pH does not change significantly. So this is how a buffer solution works. We can then calculate the pH of a buffer solution if we know the 2 points, the Ka of the weak acid and the equilibrium concentration of the weak acid and its conjugate base, which means the salt. And let's take the following example. Here, this is an equilibrium in a buffer solution. So the expression of Ka for this equation will be equal to the concentration of H plus ions times the concentration of attenuate ions CH3COO minus over the concentration of the acid CH3COOH. Then from here we can rearrange to find the concentration of H plus ions. So we can write that H plus ions concentration is equal to the value of Ka times the concentration of the acid CH3COOH over the concentration of the base. We can write that now by using the logarithm throughout. We can write that negative log concentration of H plus ions is equal will be equal to the logarithm of negative the logarithm of Ka negative the logarithm of the concentration of the acid COOH over the concentration of the base CH3COO minus. Okay, this one actually is the acid and this is the base. So from this we can write that this one is actually equal to what? Negative log the concentration of H plus is the pH and it will be equal to negative log of the Ka value. This is the pKa and here we'll be doing plus the logarithm. We reverse the sign here and then we will be reversing the base and the acid, which means logarithm the concentration of the base over the concentration of the acid. And actually this is the relation you will be using if you are asked to calculate the pH of a buffer solution. Okay, thank you for watching and goodbye until next video.